The National Electrical Code does not specify a specific length requirement above the roof line that mandates guy wires or straps to support a mast. However, the National Electrical Code states in Article 230.24, the mast shall be supported by guys or straps spaced not more than 6 feet apart. While there is no explicit length requirement, several factors should be considered when determining if guy wires or straps are necessary. Firstly, the wind load on the mast will increase with height. Therefore, taller masts are more likely to require support. Secondly, the weight of the service entrance cables can also affect the load on the mast. Heavier cables require more support. Thirdly, local building codes may have additional requirements for supporting masts. Considering that the current weatherhead is at a low height, it is likely that guy wires or straps are not required by the National Electrical Code. However, it is always advisable to consult with a qualified electrician and check local building codes to ensure compliance. If the mast is not supported by guys or straps, it is important to ensure that the roof soffit is strong enough to support the weight of the mast and cables. If guy wires or straps are used, they should be properly attached to the mast and securely anchored to the ground or a suitable structure. It's crucial to understand the relationship between mast height, wind load, cable weight, and local code requirements. The National Electrical Code provides a baseline for safe electrical installations, but local jurisdictions often have amendments or additional requirements that must be followed. Therefore, relying solely on the National Electrical Code without considering local codes can lead to non-compliance and potential safety hazards. When evaluating the need for guy wires or straps, start by determining the total height of the mast above the roof line. Taller masts are exposed to greater wind forces, which can create significant stress on the mast and its attachment point to the building. Next, assess the weight of the service entrance cables that the masts will support. Larger conductors, such as those used for 200 amp service, are heavier than smaller conductors and will exert more downward force on the mast. Combine these factors to determine the overall load on the mast. If the load is substantial, guy wires or straps are likely necessary to provide adequate support. Remember that the 6-foot spacing requirement for guy wires or straps, as stated in the National Electrical Code, is a maximum. Depending on the load and the mast's structural integrity, closer spacing may be required. The type of material used for the mast also plays a role in determining the need for support. Steel masts are generally stronger than aluminum masts and can withstand greater loads without bending or breaking. However, even steel masts may require support if they are excessively tall or subject to high wind loads. The attachment of the mast to the roof soffit is another critical consideration. The soffit must be strong enough to support the weight of the mast and cables, as well as any wind or ice loads. If the soffit is weak or damaged, it may need to be reinforced before the mast is installed. When installing guy wires or straps, it is essential to use the correct hardware and techniques. The wires or straps should be made of galvanized steel or another corrosion-resistant material. They should be attached to the mast using clamps or brackets that are specifically designed for this purpose. The other end of the wires or strap should be securely anchored to the ground or a suitable structure, such as a concrete foundation or sturdy wall. The anchors should be installed in accordance with the manufacturer's instructions and should be able to withstand the anticipated loads. It is also important to ensure that the guy wires or straps are properly tensioned. If they are too loose, they will not provide adequate support. If they are too tight, they may put excessive stress on the masts and the anchors. The proper tension can be achieved by using a turnbuckle or another tensioning device. In addition to guy wires or straps, other methods can be used to support a service mast. One option is to use a mast that is designed to be self-supporting. These masts are typically made of heavy-duty steel and are designed to withstand high wind loads without the need for additional support. Another option is to use a through-the-roof mast. These masts extend through the roof and are attached to a structural member inside the building. This provides a more secure and stable support for the mast. When choosing a method of support, it is important to consider the specific requirements of the installation and the local building codes. A qualified electrician can help you determine the best solution for your situation. Remember that electrical work can be dangerous. It is important to take precautions to protect yourself from electric shock and other hazards. Always turn off the power to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Failing to properly support a service mast has serious consequences. If the mast collapses, it can damage the service entrance cables, which can cause a power outage. It can also create a safety hazard, as the fallen cables may be energized. In addition, a collapsed mast can damage the building and surrounding property. Therefore, it is essential to take the necessary steps to ensure that the service mast is properly supported. This includes considering the wind load, the weight of the cables, the local building codes, and the type of mast being used. It also includes using the correct hardware and techniques when installing guy wires or straps. By following these guidelines, you can help ensure the safety and reliability of your electrical service. Now, let's consider some additional details about the National Electrical Code requirements for service masts. As mentioned earlier, Article 230.24 of the National Electrical Code states that the mast shall be supported by guys or straps spaced not more than 6 feet apart. This requirement applies to all service masts, regardless of their height. The purpose of this requirement is to prevent the mast from bending or breaking under the weight of the service entrance cables or the force of the wind. The National Electrical Code also contains requirements for the size and type of conductors that can be used for service entrance cables. These requirements are based on the ampacity of the service and the voltage drop in the conductors. It is important to choose conductors that are large enough to carry the load without overheating or causing excessive voltage drop. The National Electrical Code also contains requirements for the type of raceway that can be used to enclose service entrance cables. The raceway must be suitable for the environment in which it is installed and must be able to protect the conductors from physical damage. Common types of raceway used for service entrance cables include rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. The National Electrical Code also contains requirements for the grounding of service entrance equipment. Grounding is essential for protecting people from electric shock and for preventing damage to electrical equipment. The grounding system must be properly installed and maintained in order to be effective. In addition to the National Electrical Code, local building codes may have additional requirements for service masts and service entrance equipment. These requirements may vary depending on the jurisdiction. It is important to check with your local building department to determine the specific requirements that apply to your installation. When planning a service entrance installation, it is important to consider the location of the service mast. The mast should be located in a place where it is easily accessible for maintenance and repair. It should also be located away from trees, buildings, and other obstructions that could interfere with the service entrance cables. The mast should be installed in a vertical position and should be securely attached to the building. The service entrance cables should be installed in a neat and workmanlike manner. They should be properly supported and protected from physical damage. The connections to the service entrance equipment should be made using approved connectors and should be properly tightened. After the service entrance installation is complete, it is important to have it inspected by a qualified electrical inspector. The inspector will verify that the installation complies with the National Electrical Code and local building codes. If the installation is approved, the inspector will issue a certificate of compliance. Maintaining a service entrance installation is essential for ensuring its safety and reliability. The service mast, service entrance cables, and service entrance equipment should be inspected regularly for signs of damage or deterioration. Any problems that are found should be corrected promptly. The grounding system should also be tested periodically to ensure that it is still effective. Service entrance installations can be dangerous if they are not properly installed and maintained. It is important to take precautions to protect yourself from electric shock and other hazards. Always turn off the power to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. In summary, determining whether guy wires or straps are required for a service mast involves considering several factors, including mast height, wind load, cable weight, and local code requirements. While the National Electrical Code does not specify a specific height threshold, it mandates that masts be supported by guys or straps spaced no more than 6 feet apart. Consulting with a qualified electrician and checking local building codes are essential steps to ensure compliance and safety. Remember that proper installation and maintenance are crucial for the long-term reliability and safety of the electrical service. By following these guidelines, you can help ensure that your service mast is properly supported and that your electrical service is safe and reliable.